This question now, question 10, is vectors and matrices. So we need to calculate the matrix product of 5, 4, minus 3, minus 2 times this matrix right here. So remember, how do we multiply matrix? We go row by column. Remember, it is row by column. All right? Okay, now we have a little more space. So now, remember, this is now equal to first row, first column, 5 times 2 plus 4 times 0. Then right here, this element is going to be 5 times 1 plus 4 times 3. Then this one is going to be 5 times negative 4 plus 4 times 6. And then this right here is going to be this row by this column, negative 3 times 2 plus negative 2 times 0. Then this element right here is going to be negative 3 times 1 plus negative 2 times 3. Then this element right here is going to be last row, last column. That's negative 3 times negative 4. Negative 3 times negative 4 plus negative 2 times 6. Just going to write minus 12 due to lack of space. So all of this works out to be 5 times 2 is 12. 5 times 2 is 10, not 12. 10. 10 plus 4 times 0, that's 10. Then 5 times 1 is 5. 5 plus 4 times 3. 4 times 3 is 12. 12 plus 5 is 17. 5 times minus 4. 5 times minus 4 is minus 20. Minus 20 plus 24 is 4. This is now minus 3 times 2 is negative 6. Minus 3 times 1 is minus 3. Minus 3 plus 3 times minus 2. 3 times minus 2 is minus 6. Minus 3 minus 6 is minus 9. Then minus 3 times minus 4 is 12. 12 minus 12 is 0. So that's it right there. Nice. Now it says state why the two matrices are conformable for multiplication. So why is this matrix product compatible? This matrix product is compatible. Let's write why. So let's write down why this matrix is compatible. So we can tell them that this matrix is compatible since, write down the order of A. A is A, 2 by 2. A is A, 2 by 2. B is what? B has 2 rows and 3 columns, 2 by 3. So what we can tell them is since the number of columns of the first matrix equal the number of rows of the second matrix, hence their product matrix is compatible. All right, so that's the reason. The reason why we're able to multiply them is because the number of columns of the first matrix is equal to the number of rows of the second matrix. That's the reason why we're able to multiply them. Nice. Okay, let's look at the next part. The next part says determine the inverse of this matrix right here. Let's call this matrix A. If we call this matrix A, we need to remember that the inverse of any matrix, let's call it A to the minus 1, it's 1 over the determinant of A multiplied by the adjoint of A. So first we need to find is the determinant. The determinant of A is equal to this number right here, the 5 times minus 2, it's product of the leading diagonals minus the product of the non-leading, which is 4 times negative 3. So what we end up getting is 5 times minus 2 is minus 10. Minus 4 times minus 3, that become plus 12. Minus 10 plus 12 is indeed 12 minus 10, which is 2. And so therefore, the inverse is then going to be 1 over the determinant, 1 over 2, times the adjoint. The adjoint is we interchange the first term and the fourth term, the first and the last, we exchange them. So the minus 2 come here and the 5 come here. Then we negate the B and the C term, the second and the third term in the matrix. So this becomes negative 4, and the negation of negative 3 is 3. So that's going to be the inverse of the matrix A. Nice. And we'll finish with matrices just like that. Really done with matrices, just like that. Nice. Now this question is now the vectors part. All right, so we'll finish the matrices part now onto vectors. And this question, it says, in the diagram, it shows triangle OAB, in which OA is R. So to go from O to A, all of this is R. And to go from O to B is S. Go from O to B is S. And it says now, in addition, E is the midpoint of CD. OA is 3/4, OC is 3/4 of OA, and AD is 2/3 AB. Now we need to work out what is vector CD. Now to go from vector C to D, we can go from C to A. Yeah, man, we can go from C to A, then we can go from A to D. How do that now? So to go from C to D, we can go from C to A, then we can go from vector A to D. Now what's vector CA? Going from vector C to A is, remember, OA, all of this is R, right? All of this is R. Now, at this point right here, which is C, they say OC is 3/4 of OA. So that means that down here, so I'm going to be 3/4 R. That part here is 3/4 R. And so that means that this top part is just 1/4 R. So to go from C to A is just going to be 1/4 R. Okay, plus going from vector A to D. But vector A to D is 2/3 of AB. So this is going to be 2/3 of vector AB. But what is vector AB? Vector AB is OB minus OA. Vector AB is OB minus OA. So let us go ahead and finish off this with the final touches. This is going to be 1/4 R plus 2/3 of OB. Remember, AB is OB minus OA. This is vector AB. So OB minus OA, if you work that out, it's going to be OB is S minus OA is R. So we end up get 1/4 of R plus 2/3 of S minus 2/3 of R. And so we work that out now. We just need to add 1/4 and minus 2/3. 1/4 minus 2/3, that's not coming to me straight away. So I'm just going to use the calculator to help me to simplify. 1/4 minus 2/3. This is to simplify the R parts then together. That's minus 5/12. So CD is minus 5/12 R plus 2/3 S. That's your answer. Minus 5/12 R plus 2/3 S. Nice. Now the next part says work out what is going from vector O to E. Now vector O to E, now since we already know what vector CD is, and it says that E is what? E is the midpoint, don't it? Yeah, man, E is the midpoint of vector CD. Now, since E is the midpoint, right, then to go from O to E, then what we can do is maybe you want to go from O to C, and then you can go from C to E. You can do that. You can go from O to C, and then go from C to E. Maybe you want to do that. It's up to you. All right. So now we'll go from O to C. Going from O to C, What's OC? Going from O to C is 3/4 R. See it here? O to C is 3/4 R. So going from O to C is 3/4 of R plus going from C to E. Going from C to E is going to be half the journey of going from C to D. So it's going to be a half the full journey of going from C to D. So it's a half of 5/12R plus 2/3x. Then all we need to do now is simplify. So now we need to simplify. So we're going to, of course, simplify. Let's simplify this. This is going to be 3/4 R. A half times minus 5/12, that is minus 5/24 R. Then half times 2/3 is this 2 cancel this 2, that becomes plus 1/3 times S. So finally, 3/4 minus 5/25. I will put that in my calculator because I am not stressing that. 3/4 minus 5/24. No need to stress about those. Put it in the calculator. That's 13/24. This is 13/24. Why is it not writing better? 13/24R. All right, let me try and fix this. It's not giving me the way I want it to write. I'm going to try and rewrite all of this. Equal to, need it to look prettier, more presentable, 13/24R, good, plus 1/3x. That's our answer. Nice. Okay, we're almost finished. We're almost finished. Nice. We're almost finished. Okay, now the next part, it gives us a graph and it tells us that the point O, Q, and R have coordinates 0, 0, 5, 2, and -1, 4. Okay, and it says write OR as a column vector. So first thing is the points O, Q, and R. So R is the last one given, -1, 4. This is R. So to write it as a column vector, we don't have nothing much to do. Let's write it as a column vector. Vector OR as a column vector is equal to -1, 4. That's all. Okay, I'm gonna do nothing. What next they want? Determine the magnitude of QR. Now, before we can find the magnitude of QR, we need to find vector QR. Vector QR is OR minus OQ. So work out OR minus OQ. OR, which is -1, 4, minus OQ. OQ is this point, which is 5, 2. When we subtract them, -1 minus 5 is -6. 4 minus 2 is 2. And so therefore, this modular sign means the magnitude. So the magnitude of vector QR is equal to the square root of the x component square, -6 square, plus 2 square. -6 square is 36, plus 2 square is 4. That's the square root of 40. The square root of 40 is the length of QR. That's it. You can leave your answer like this, but let's say you like to give your answer in decimals. You can just put it in your calculator. Put it into your calculator, the square root of 40. All right, you put that in a calculator and let's just do that right here. Square root of 40, see it there? Square root of 40 is 2 root 10. And some people might say 6.32. So that's the length of vector QR. So if you go back around here, this length right here is 6.32 units. Okay? Nice. So that is it. That takes care of the July 2021 paper. I hope this was very fun for you as it was for me. Stay